As I said before, I don't want these book reviews to be your classic standard book reviews, more so an overall encompassing understanding of life in general. And so with the book called Oil, I think it's only right that we dive into a little of the science behind oil in the oil industry. Now, when you drill into the ground, you receive from the ground crude oil or crude petroleum. But you can't use that crude product to fuel your cars or your planes. Before you can have a usable product, the oil must be refined in an oil refinery. Now, one of the first steps in refining oil into a usable product is called distillation. Now, there are several different types of distillation, but the distillation that I'm going to be attempting to explain today is called fractional distillation. Crude oil is made up of a mixture of different hydrocarbons, compounds of hydrogen and carbons, or H's connected to C's. So in fractional distillation, we are attempting to separate the hydrocarbons that are mixed together in the crude oil by using the application of heat. The heat is to bring the liquids to a boiling point so that they vaporize, rise through the column, which is where this is taking place, to their appropriate level where they're meant to cool, condense, and then be collected on a tray that is designated for that specific hydrocarbon. So in order to separate these appropriately, each level of the column has a different temperature that is set just below the boiling point of the hydrocarbon that is the target hydrocarbon for that level. Because the temperature is set below the boiling point temperature, that specific liquid is no longer hot enough to boil and vaporize, and thus the vapors will cool and condense and then return to a liquid state and fall into a tray which catches it and collects it and is taken out of the column. Okay, so I'm aware that you still all might be pretty confused about fractional distillation, so I'm going to try to explain it in a different way using a deck of cards for an analogy. So imagine your crude oil as a mixture of hydrocarbons. Like I said, it's just like a mixture of a deck of cards that aren't shuffled. So you have all these cards all mixed together, and that somehow we have to organize them and separate them by number. Okay, so for this example, we have your different hydrocarbons, the 6s, the kings, and the 3s. The kings are the heaviest hydrocarbons, the 6s are less heavy, and the 3s are the lightest. Here you have your vertical column, which all of this distillation is taking place, and from below there's a furnace that's heating all of the hydrocarbons. So what's going to happen is we need to separate all of our hydrocarbons. So we apply heat and we cause these to boil. But what happens is it's too hot for the smaller hydrocarbons like the 3s or 6 at this bottom stage of the column. So they vaporize, and when they vaporize, they rise. So they move up to the next level. But this temperature is set just below the boiling point of the kings. So these don't boil. So they don't vaporize and they don't rise. So they are left behind. So now you have one liquid already separated. Now a similar process is going to take place all the way through the column. So when we reach this next step of the column, we have your 6s and your 3s, and you have the temperature set at this level just below the boiling point of the 6s. So the larger the molecules, the higher the boiling point. So the lower the molecules, the lower the boiling point, which means you don't need as much heat to make these boil. So with the temperature set just below the boiling point of the 6s, it's still too hot for the 3s to hang out, so they continue in a vaporized state and they rise up to the top of the column. But for the 6s, because it's just below their boiling point, it's not hot enough for them to continue in a vaporized state. So they cool, they condense, and then they liquefy. And when they become liquids, when they return to their liquid state, they are collected in a tray here, and then they are collected out the sides of the columns. So now we have 2 of the hydrocarbons separated. And then the process repeats itself until all of the numbers are separated into their appropriate place. And at the top you have your petroleum gas, you have the gasoline, you have your naphtha, and at the bottom you have your heavier hydrocarbons for lubricating purposes or for heavy greased material. Now I understand that that still might be overly complicated, but I tried to simplify it to a point of almost being incorrect, because I just wanted to give an overall view of the oil world and help you observe oil in its entirety. So I hope that little demonstration about oil refining and distillation gives you a little bit of insight that you didn't have before. So